The global textile industry operates under a severe delusion regarding animal fibers, treating them as efficient, natural systems. The reality is a catastrophic model of industrial waste, propped up by romanticized marketing rather than actual operational logic. Consider the processing of animal hides, a sector fundamentally defined by massive material loss and primitive supply chains. Data reveals an industry incapable of utilizing its own raw inputs efficiently, leading to extreme financial and environmental deficits. According to the United Nations Industrial Development Organization, processing 1,000 kilograms of raw hides yields a fraction of usable material. You are left with only 200 kilograms of finished leather. This means an astonishing 80% of the initial mass is discarded as solid waste, including fleshings, hair, and toxic sludge. The system forces you to transport and treat raw material where the vast majority is destined for immediate disposal. The logistical chains are actively collapsing under their own structural inefficiency, particularly in major processing hubs across South Asia. Operators are facing plummeting raw material values, forcing them to work at a significant financial loss or exit the business entirely. In Bangladesh alone, reports indicate that at least 30% of collected hides rot away annually. This is caused by primitive storage capabilities, processing errors, and a total inability to manage the volume of biological decay. The wool industry hides behind a carefully constructed illusion of pastoral sustainability and natural purity. Yet, examining its raw operational data reveals a legacy system that is equally broken and fundamentally unprofitable. Raw, greasy wool, sheared directly from the animal, is not a clean fibre ready for sophisticated spinning. It is heavily contaminated, containing massive amounts of lanolin, suint, animal feces, and trapped agricultural vegetation. Based on international yield statistics, up to 50% of raw wool weight is essentially biological waste. The global supply chain is literally paying to ship dirt across oceans, only to violently wash it out upon arrival. This cleaning process, known as scouring, requires massive consumption of water and aggressive chemical detergents. It generates highly toxic effluent, often laden with heavy metals, from the pesticide dips used on the living animals. The economic viability of this fibre is deteriorating at an alarming rate, particularly for coarse wools tied to the meat industry. The return on investment has completely inverted. The market price for this raw material has fallen so low that the economic model has broken down. In many regions, it now costs more to pay the shearers than the resulting fleece is actually worth on the market. Consequently, farmers across the UK and New Zealand are forced to treat the wool as a hazardous byproduct. They are actively burning the fleeces in fields or burying them in trenches as useless agricultural waste. The market's response to this crisis has been flawed, focusing on creating direct, plant-based imitations of these exact materials. This search for botanical leathers and vegan wools is a strategic dead end that ignores the core problem. Attempting to imitate the look and feel of leather usually requires compromising the material's integrity. Most of these alternatives rely heavily on petrochemical binders, like polyurethane, to hold the weak organic matter together. We must stop trying to imitate failure and shift our focus entirely toward functional evolution. We must isolate the performance metrics. We do not need animal skin to block wind, and we do not need hair to retain heat. The solution lies in advanced structural plant engineering, utilizing fibers that grow with purpose and yield close to 100%. We leverage high-density woven Bast fibers, such as industrial hemp and linen. These highly engineered plant structures deliver extreme tensile strength and uncompromising abrasion resistance. They outperform legacy animal skins without the 80% material loss or the highly toxic tanning infrastructure. Thermal insulation is achieved precisely through the physical geometry of hollow plant fibers, like kapok, utilizing trapped air for heat retention. No scouring, no burning of excess material, and no heavy metal contamination. This is the required industrial reset for the modern era. We are transitioning from the high-waste chaos of animal harvesting to the precision of zero-waste botanical mechanics and clean, absolute yields.